This video lesson is going to cover titrations, not only the technique, but more importantly, the calculations involved at different parts of a titration. A titration is graphed along a curve, which is known as a titration curve, and the different parts of the titration curve are extremely important when understanding the full situation that is a titration of an acid with a base. So we'll first start talking about the technique. What is a titration? A titration is defined as a controlled addition of an acid and base together. When the acid and base come together, they neutralize one another in the form of a neutralization reaction. A neutralization reaction is one where an acid and a base react together to create water in the form of HOH or H2O and the AB aqueous ionic substance, as represented over here. So in other words, acid and base make water and an aqueous salt. Now, one of the most important aspects of a titration is what is known as the equivalence point or the end point. Now, I don't necessarily like to call it an end point because that assumes that the titration is over at the end point. I prefer equivalence point, or also sometimes referred to as the neutralization point. But at that point of a titration, the moles of the acid and the moles of the titrated base, or the moles of the titrated acid with moles of the base, are equal to one another. Another more broad way of saying this is that the equivalence point is where the moles of the titrant added equals moles of the analate in the original solution. The titrant is what gets titrated, and the analate is what gets analyzed. Titrant gets dropped in from above, analate gets mixed down below. So if I were to sketch out a general form of titration, I would have the burette filled with the titrant above. Now the titrant is either acid or base, and the analate is the opposite of whatever the titrant is. If the titrant is acid, then the analate in this case would be base. Now typically in the titration, the titrant is of a known concentration, so you know exactly what the concentration is up top, but the analate is of an unknown concentration. And the whole goal of a titration is to determine the unknown concentration of your analate using stoichiometry. When doing a titration, you want to make sure to stop the titration at the equivalence point so that you can accurately measure the unknown concentration. Now there's two ways that we use, or two ways that we do identify the equivalence point in a titration. And the first one is using an acid-base indicator, sometimes referred to as a pH indicator. And those indicators are dyes that change color when a pH threshold has been reached. Now you may be familiar with phenolphthalein, which is the one that we use most often because it changes pH at 7 or slightly above 7, and it goes from a clear to pink depending on if you're in an acid or base. But there are different pH indicators that may change different colors depending on what pH you want to end your titration at. Or it depends on which combination of acid and base you're using, because not all, and this is a spoiler, but not all titrations have an equivalence point where the pH is equal to 7. Some have pHs above 7, and some have pHs below 7 at the equivalence point. And that is a very common misconception that the equivalence point is reached when the pH is 7. No, the pH has nothing to do with the equivalence point. The equivalence point is when the moles of acid or the moles of analate equals the moles of titrant. So a pH indicator allows us to know at what pH, if we knew a little bit ahead of time when the equivalence point was going to be reached, we could use the indicator to help us. Now the other way to do this is to use a pH probe. Now an advantage of a pH probe is you have an exact number because it's an electronic device that reads out a value of pH. Now the downfall or the limitations of the pH probe is that they are the least precise at or around 7 pH. They work best at pHs that are below 7 or above 7, and they're the least precise at around 7. And so that's one advantage of pH probes, but a disadvantage of pH probes all at the same time. Now we will actually use pH probes in our labs because that's what we have available to us. And they are ideal. pH indicators are tough. Sometimes the color change is subtle, like you go from a blue to a green, and it's very hard to know when you've hit that pH threshold exactly. Phenolphthalein is one of the only ones that changes so stark or so contrast. The contrast is so stark. pH probes give you a drip by drip, a drop by drop analysis of the pH along the process of a titration. And I'm going to finish up this slide, and I've talked about it a little bit before, but the titration curve is a very important picture or graphical representation of a titration along the entire process from beginning to end. It is a graph that represents the pH on the vertical axis, and it compares it to the milliliters of titrant added. Now, if you were titrating an unknown acid, you'd expect your initial pH to begin below 7. And as you add titrant to it, the graph begins to look a lot like an S-curve, like so, where the vertical component is known as the endpoint or the equivalence point. Graphically speaking, you know you've reached the equivalence point at the steepest part of the curve. I've outlined it as a dotted line in red here. This is a curve of titrating an acid with a base, and so you'll see the pH go up. But what would a titration curve look like if you started with a base like this, up above 7, and titrated it with an acid? And as you'd probably expect, it looks a lot like the other one, just you start high and finish low. So they start high and they swoop down in a downwards trending S-curve like this. Once again, the equivalence point can be determined graphically by the aspect of the line at its most vertical point. And by doing so, you can actually estimate the pH at which the titration reaches the equivalence point by simply doing a little extrapolating on the graph. At the most vertical point, you can draw a line over to the horizontal part and notice that in this particular titration, the pH at equivalence is slightly below 7. Titration curves are an essential part of this chapter, and they're an essential part of the AP test. And knowing everything about them is really, really, really useful when you're going to do well and find success on the AP test. And so these next couple of slides are going to talk about the different types of titration curves. And yes, there are different types. It all depends on the strength of your acid and your base, or in other words, the strength of your analate and the strength of your titrant.